Yo, guys, welcome back. Episode 37 today, I think. Right? Because we did 36 yesterday. Yeah, we did the Flareon. So, yeah, today's 37. We got a Porygon today. I was playing around today a little bit with the YouTube, streaming. I got to kind of figure it out with my OBS how to exactly set that up and make that work. I feel like that's probably most likely going to be a weekend thing just because I get off late in the evenings and I pretty much just want to record this video and get some rest because I'm really tired from the whole day. So I think I'm away this weekend again because I'm playing pickleball with a buddy in Indiana playing another tournament. So probably won't be till I think the first day we're going to stream will probably be Juneteenth, which will be the public holiday, which is on Thursday. So about a week from now. So probably keep it the same for about a week and a half roughly. And then I think on Juneteenth we're going to change it up and I'll stream for the first time, get it all set up that day, do the video. And then, for the rest of the videos when I come back after work, I'll, know how to do them easily and it'll be easier to edit them and so forth, blah, blah, blah. But yeah, also appreciate all the comments everyone's been giving me on the videos. It's kind of crazy to see people actually kind of watch these videos, which kind of surprises me. I mean, when I first started, I was getting literally 2 views a video, but now people actually watch, so that's kind of cool. And I appreciate everyone that watches this video and, leaves a comment and, encourages me to keep going because it really does encourage me to keep going, and I really do love making these videos. They're kind of fun. So, but yeah, appreciate all that. So thank you to everyone. We're going to jump in and we're going to take a look at the Porygon sound today. Porygon 137. Oh, Porygon sound. Pokemon sound. Ooh. Got a star today on my left eye too over here, bro. It hurts so bad.
Great ideas can come from anywhere.
There's our Porygon sound. Probably the worst Porygon sound ever, but that is our sound. And that is bright. Jeez. God, get me to the dark mode. Yeah, so we're not gonna solve this problem, but we're gonna keep going with our study plan over here. Probably gonna do another, finish it off a little bit. We got the non-overlapping intervals, which we have completed before. Maybe we can take a look at one of these ones here that we haven't done either. So let's take a look at the non-overlapping intervals. We have solved this one, and it was on a video, but it was a little while ago, May 18th. Oh, gotta reset that. Whoops. Sorry. Given an array of intervals, where intervals I is equal to start I and I, return the minimum number of intervals you need to make the rest of the intervals non-overlapping. Well, 1, 2, and 2, 3 are non-overlapping. 1, 2, 2, 3. Intervals which only touch at a point are non-overlapping. Okay. So my first idea here for this problem, the first thing that comes to my head is that I think you have to sort this. That's the number one thing. Reason is because I feel like we're going to probably use some sort of, probably just a for loop, right? And loop over each of these, okay? And I think the most important thing here is that we have to move this and make it here. So we're going to sort based on the first number here, right? Sort based on the first number. We need to remove 2, 1, 2 to make. So what are we counting though? Given the array number of intervals, so I return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Okay. Okay, there you go. First thing I look, sort given intervals based on starting points. Okay, so there's a few ways we can do that in Python. We can do a simple list comprehension with, well, actually a, what are they called? Lambda function. I don't know what it is with me, man. I've been doing these videos for 6 months, but I find lambda functions, at least the syntax, really difficult. So let's take a look at the internet, how we do lambda functions in Python again, because I can never remember how to do it. Lambda functions, Python. Okay, let's do intervals is equal to, so obviously we're gonna sort it, right? Intervals is equal to, I don't know the syntax, man. I know we're probably gonna do sorted first. I guess we just gotta ask, we gotta ask GPT about this because I'm honestly not sure. How to sort a list based on first number in a list of a list. Python. Okay, so I was right. We got intervals. Let's do sorted intervals is equal to sorted data. Well, actually, no. Well, I guess we got our intervals. Key is equal to lambda. We got an x here, and then we want 0. Print sorted intervals. So that worked. Okay. Got 1, 2, 1, 3, 2, 3, 3, 4. Okay, so now what we want to do is we probably want to look at, well, if we think about it, if our first number, so I guess we'd have to compare this number to this number, right? Because if the last number here is greater than this number, then we can just count, right? Well, technically in this, we don't really need to remove it, bro. We just need to count, right? So I guess technically if we would loop through here, but I don't know if that would work. I'm thinking we could just loop through this whole thing and count, right? So if this is here and this is here, then we go to the next one, right? Then we go from here and we check, okay, is this one and this one? If it is, count, blah, blah, blah. Because really technically all we need to do is count, solve this problem. So I think we do, okay, so for I in, I'm going to do a range because I don't know if I'm going to need the index or the actual thing. We can do sorted intervals. And we can do, let's start at 1, right? Let's print our sorted intervals I. 1, 3, 2, 3, 3, 4. Let's do our first tuple is equal to I think here. First tuple is equal to sorted intervals 0, right? Okay. Then we would do, okay, well, we want to do an if statement here. We want to check, well, if sorted intervals 0, 1, I think that gets the second value, right? Because we want to compare this value to this one. Sorted interval 0, 1 is... Sorry. Sorted intervals I 0 is greater than I1. Sorry, I0. First tuple. Is that how you would? I don't know. I think so. Sort first tuple 1 is greater than sorted intervals I 0. And we would add to our count, right? We obviously need a count variable too. So let's add count. Right? If it isn't, then we make first tuple equal to sorted intervals I. Right? Okay, we make it equal to that, and then we keep going. Okay, let's return our count. I think this is way too easy, so there's definitely something wrong here, but... Okay, here we get 2. Why would we get 2? Alright, so we come through here, we get 1, 2. So obviously this is thingo, right? One, 2, 1, 3, 2, 3, 3, 3. How would you expect a 1? I think this is right. Isn't it 2? Like what, bro? 1, 2, 2, 3. I don't know what we're missing here. We make a use of pointer prev. For everything we'll just include in the final list. Okay, I am not sure. I'm not sure. Why are we... I think we're close, but we're missing like a key concept, I think, but I'm not sure exactly what we're missing here. Non-overlapping intervals. It's almost correct, but there's a small issue. Always keep the current interval when overlap is found. So I think what we're missing here is we need an else here and then call this. Because it's saying here, but there's a small issue in how you choose which interval to keep when there's an overlap. But this can lead to more future overlaps instead. To minimize the number of intervals to remove, you should keep the interval with the earlier end time because it's less likely to overlap with future intervals. Okay. Okay, so that was our issue. We needed that in the else. Well, that was an interesting fix. So, oh, well, never mind. We didn't fix it. Okay, What are we missing here now? 100. Okay, so we're obviously overlapping here. We're obviously overlapping here. I think we're still overlapping. So they're saying that it's my sort. In my sort. We need to sort by the second number. Why would we sort by the second number? So we've got 2 here. Apparently we need to sort by x1 instead. Or y. One, two, three. This is not overlapping. Okay, so we move here, then we see this is overlapping, then we would move. Man, these some sort of tricks, man. Playing tricks on me. Okay, well that worked. We will leave it at that. Let's take a look at our next problem. That was an interesting problem. I mean, it was a little, we had the idea, but yeah, maybe could have executed it better. Maximum arrows to burst balloons. Let's go this problem. There are some spherical balloons tapped onto a flat wall that represents the XY plane. The balloons are represented as 2D integer array points where points I is equal to x start, x end. Denotes a balloon whose horizontal diameter stretches between x start and x end. So, okay, you do not know the exact y coordinates of the balloons. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x. If x start is less than x end, there is no limit to the number of arrows that can be shot. Shot arrow keeps traveling up, infinitely bursting any balloons in its path. Given the points, return the minimum number of arrows that must be shot to burst all the balloons. Okay. So in this explanation here, so we're considering these as points on a 2D, on an XY plane. So 10, 16, 2, 8, 1, 6, 7, 2. The balloons can be burst by 2 arrows. Shoot an arrow at x is equal to 6. Y 6. Shoot an arrow at x is equal to 6, bursting balloons at 2, 8, and y and 1, 6. I don't understand how it's bursting those. I don't get it. Oh, okay. There are some spherical balloons taped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points, where points I is equal to x start, x end. Okay. Denotes a balloon whose horizontal diameter stretches between x start and x end. You don't know the exact y coordinates of the balloons. Okay, so this represents 2x coordinates. Okay. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x start is less than or equal to x end. There is no limit to the number of arrows that can be shot. So 2, 8, and 1, 6. So they shoot it at x6 because I think it getting to think that this is like getting the idea that this is a interval problem. So I'm thinking they shoot at x equal to 6 because 6 lands between both of these. And they shoot an arrow at 11, bursting the balloons 10, 16, and 7, 12. I guess that kind of makes sense, but I'm not really 100% sure. Here, they need 4 arrows, right? Because yeah, none of these overlap. 2, 3. Well, really, now that I think about it, I think this is probably the way to do it. This is probably a really smarter way to do it, right? Considering these are pretty much what they're counting here is they're counting the overlaps here, right? That's what kind of I've got from this problem is that they're literally counting the amount of overlaps. Because if you think about it, we sort this again, right? And if they overlap, then we just count it, right? And then we divide the counts from the total. Or we can somehow get that value, I think. Because we have 2 overlaps and 4 thingos, then we divide it by the amount. But what if it's odd? I don't know. I think I have the right idea here, but this is the part where I say, oh man, I did chest today, man. My chest hurts so bad. Okay, let's figure that out. So it comes back to the lambda function, man. Let's do our sorted points is equal to, how did we do it? Well, we had sorted, right? Now we did, man, I don't remember, dude. Just goes in and out of my head, dude. Okay, we need the actual points, right? The data. Then we have the lambda function. Lambda x. Oh, sorry, key is equal to lambda. I need to get like a Python mouse pad or something, man. Help me remember. X, right? We want to sort based on I don't know. Based on x0. Let's print our sorted points. Maybe we didn't sort this properly. I feel like, I think about it, this problem is going to be a little similar to the other one. This is the part when I say how you want it. Okay, for I in range length points, right? We're gonna loop through. We're gonna do, well, we need to make a default one. We need to go from 1 to this, right? We make, okay, well, literally same code. First tuple is equal to point 0, right? And we can do, well, if first tuple first tuple 1 is greater than points I 0, we increment our count, else we would move first tuple, sorry, we would make first tuple equal to points I, right? We obviously need our count. This is literally looking the exact same as our previous code, But what we want to do here is that after we get through the 4, what we want to do here is we want to do, well, let's do res. Res is equal to the length of points minus, divide by our count. I don't know if this is going to work properly. I think it's probably going to, I mean, it will mess up for odd numbers, but. How do I do this? Integer zero division error. Integer division by or modulo by 0. I don't know what that means. Division by 0. Oh. If res is equal to 0, just return count. Otherwise we do that. Otherwise we do this. We return res. So if count is equal to 0 else, res. Mm-mm. 1, 0, 0. Okay. I really do believe that we're thinking about it the right way. Wait, what am I doing, dude? Holy shit, am I not thinking? We're not even using... No. Let's check how 452 minimum number of arrows to burst balloons. We're close again. Oh shit, we're using normal points? Oh shit, sorted points. And this is the part where I say how I want it. Okay, again, they're sorting it based on the first number, dude. Instead here, they didn't do the else here. Maybe not. We don't need to divide that because we're returning the minimum number of arrows to be shot. Right, so technically we'd return count. Because if we're looping through here... So we're doing the lambda function here, we're doing a count. 2 is equal to 0.0. Yeah, dude. I don't know what we're doing wrong here. I generally don't know. Oh my god, really? That's my issue? Sorted points, yeah. Four. Here I'm counting the overlaps. Maybe I think I probably shouldn't be counting the overlaps, right? Like, wait. Wait. Sorted points. Print sorted points. We make our count. Make our first tuple equal to first value. We set the for loop. We check, well, if this number here is less than this one, that doesn't work. It has to be the other way, right? First tuple is greater than this. We continue. There's a way better way to do this, but else we do this. Expected 2, output 3, expected 4, 3, 2. What I'm thinking here is that maybe we should be counting. There isn't an overlap, right? Right, because if we count if there isn't an overlap, yeah, that's what we should be doing. We should be counting if there is an overlap. We make our count 1, right? Because if there is no overlap, we always have 1 to return, right? If there's an overlap, then we have 2. But, you know, there can always be 1. So that's why we make our count 1. Okay? We loop, and we have to check, well, if there is no overlap, right? Oh, it has to be equal to. Okay, it has to be equal to. So I think I have to change it to this. There we go. There we go. I was right. Instead of counting the actual one, we have to actually count when it doesn't. Interesting problem for sure. That was a good problem though. I did like that. Oh man, getting blind, dude. Favorite study plan. Take a look at a graph theory problem. See how long we've been going for. About 34 minutes. It's fine. Man, this annoys me, dude. I don't want to subscribe to Leetcode, bro. Like, so expensive, dude. Like, $35 a month, bro. Like, really, bro? Like, unlimited playground. Like, I don't care about any of this shit. Like, I just want the questions, dude. More questions, bro. Like, I feel like I'm doing the same questions all the time. Like, you know, we're gonna attempt this problem, critical connection to network. Not today, but we're gonna do it someday. Like, I do want to attempt this hard problem. I feel like it'd be fun. But we're going to do something else. Check out nearest exit from maze. We have done this problem recently. Oh, yep. It's recently because when it loads the code, it's recent. May 6th, so about just over a month ago. Given m times n maze, your index of empty cell is represented with a dot and walls represented with a plus. You're given the entrance of the maze, where entrance blah 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 denotes the row and column you're initially starting at. Okay. So this is our entrance. They give us where we're initially starting at. Okay. In one step, you can move. In one step, you can move one cell up, down, left, or right. You cannot step into with a wall, and you cannot step outside the maze. Your goal is to find the nearest exit from the entrance. An exit is defined as an empty cell that is the border of the maze. The entrance does not count as an exit. As an empty cell that is at the border of the maze. The entrance does not count as an exit. Return the number of steps in the shortest path from entrance to the nearest exit, or -1 if no such path returns. Okay, this is pretty easy. This is a very basic length row. Cols is equal to length. Oh shit. Row 0. The length of row 0. This is a very basic, simple BFS approach with a graph. Very simple approach. What we're going to do is we're going to check the rows and the columns. Then we're literally going to import BFS from collections. BFS, I do like BFS more than DFS. Definitely. I like it better. I think it's just the best one by far. I think it's easy to implement too. Implement BFS is kind of easy to understand. So definitely I go with BFS most of the time. If I can. Okay, so what we want to do here is we want to create our queue. So queue is equal to DQ. Okay. We want to do queue.append. We want to append our entrance, right? But we want to make this, since it's a list, we probably want to make this a tuple. Okay. Probably want a visited set, right? So let's do visited is equal to set. We also need a directions one so we can move, right? So directions is equal to this. Let's do up, down, right, left, right? So up would be 0, -1, because -1 would go up in the Y. Down would be +1, so we would go 0, 1. Left would be, sorry, right would be positive in the X. And left would be negative, right, in the X. Okay. Now, literally what we're going to do is we're going to go while Q, we're going to pop, right? So let's do Q.pop left. Okay. We're going to pop. We're going to get our row and our col. Okay. And what we're going to do from here is we're going to go, okay, well, for new row, new col in directions, we're going to do, well, new row is equal to nr plus row. New col is equal to nc plus col. We're also going to check, well, we need to check if it's inside, right? So if 0 is less than or equal to new row, do less than or equal to because it can be 0, right? But it's less than rows, and 0 is less than or equal to new col, but it's less than cols. And obviously we want to make sure that it's not invisited, right? So now I think about it, we need to add it to the visited set. Visited.add, we want the tuple entrance. Okay. And new row, new col, not in visited. Okay, so it's inbounds, it's not in visited, right? Okay. Then what do we want to do here? We want to do q.append, new row, new col. We're appending this tuple. Okay. We also want to append the number of steps. I totally forgot about that, right? Obviously, we want our steps here. How can we add steps here? Okay, we'll figure that out later, right? Then we'll do here, we'll do steps plus 1. Okay. We'll add it to our visitor, visitor.add. We want our new row, new col. Okay. Really, that's really about it, right? When we pop from here and we check, well, if new row, if row, well, how do we know that it's a thinger, right? Well, if row is equal to 0, or row is equal to the length of row is equal to rows minus 1, or col is equal to 0, or col is equal to rows cols minus 1, and we know it's an edge, right? So then we can simply return our steps, right? Because BFS always guarantees the fastest time, right? So we don't really need to check if it's just the fastest time, right? Because when we return the amount of steps, BFS always guarantees the fastest time, right? Because we're going like this, right? We're discovering this, and we're discovering the ones next to it. So it always guarantees the fastest time no matter what. So we can just instantly return steps, right? But instead, if we come out of this while loop, we can just return -1, right? So the only issue that we're having here is, how do we append like this? Dude, I don't know. I don't know how this works here. How does this work? I didn't think about this. This is a better way to do it. There we go. We solved our issue. Let's run this. See what it gives us. It's just row where it's not associated with a value. Sorry, to the length of maze. I don't know what I was doing here. Maze 0. Actually, we haven't taken a step, right? This would be 1 step. Okay. We got 1 step here. Oh, we have pluses and minuses, dude. I didn't realize we had that. Oh, okay. You can understand with empty cells dot, right? So we need to know that it's a dot too. Okay, and maze, new row, new col is equal to a dot, right? Because dots represent things, right? If it's a plus, then we don't want it. It's a wall. Okay, but why am I less than row 0 is less than equal to new col, cols, and new row, new col not in visited, and maze, new row, new col is equal to dot. Visitor add new row, new col, increase the steps by 1. It does look good. I don't know what our issue could be here. I really don't. Let's maybe throw it in, see what we're looking at. It's 1 critical bug. Your code, you're checking this, so if the entrance is on the edge. Oh, that's our bug, right? I didn't think about this, right? So when we enter this loop straight away, it could be an edge straight away, right? So it's returning 0 straight up, right? Because this is an edge. That's why we're getting 0. But we have to say that it's not. We have to say and we can just do and row does not equal I guess we could do not in visited and row. Wait, not in visited. That wouldn't work. I guess we could do and the length of visited. This is kind of a bad way to do it. Does not equal 1. Okay, that did not work. Tuple entrance. Oh, say how I want it. This is why we not working. The part where turn step 0. Why are we still getting that? I think this needs to be in a bracket. There we go. Alright, sweet. Okay, well I think we're gonna call the video there. That was a pretty straightforward problem. I'm gonna take a look at our old solution, see what we did last time. A lot more code, but I guess it kind of makes sense, yeah. We're using row length. We're getting a min count. We don't really need this because, again, BFS always gives you the most minimum count. We don't really need this. But, yeah, I guess it works. Fair enough. This is probably a better solution. A lot more compact. A lot better. But, yeah. Appreciate you guys watching. And I will see you guys tomorrow.